Okay, welcome to the syllabus recap. This time the component is P1, and I'm going to quickly breeze through all the topics that are there on the P1 syllabus, and I'm going to show you all the formulas. I would strongly recommend that you have a pen and paper next to you to note down whatever you want to, and you can pause the video wherever you want. Try to solve a particular question that I've already solved, and if you feel that you don't know a particular topic, then you should go watch the detailed videos that are available on my channel as well. So beginning with the syllabus, the first chapter that I cover on the syllabus is coordinate geometry, which is why it's the first chapter in my book as well. The first thing, the coordinate geometry is nothing new to all O-level students. You do that in O-level math as well. You do the basic ideas, equation of a line, slope, midpoints, and so on. The ideas get a little enhanced here, and the questions can come up trickier than even the add math questions that are there. So you should know this topic in detail. It comes in handy when you're doing differentiation, integration as well. Then there's transformation of functions. That's also something that relies on basic coordinate geometry as well. So you need to know that. Okay, beginning with chapter 1, the first formula that I have for you is the slope, which is y2 minus y1 over x2 minus x1. When we're talking about straight lines, remember that the slope throughout the straight line remains the same. By looking at lines, you should also be able to identify when a slope is negative, positive, infinite, or 0. Horizontal lines have a slope of 0, vertical lines have a slope which is undefined or infinity, whatever you want to call it. Then I go on to the idea of an equation of a line. We first talk about what is an equation. It's basically a relationship between two variables. Basically, it connects the values of x to the values of y. When you plug in a value of x, you get a resulting value for y, and when you plug in a value for y, you get the resulting value for x. When you want to construct the equation of a straight line, hopefully everybody knows this, that you need two things. You need the gradient and you need one set of coordinates. Now I've often seen people not aware of this formula. This enables you to calculate the equation of a line very quickly. Y minus y1 equals to mx minus x1. It's also called the slope intercept form of not the slope intercept form, slope point form of the equation of a line, because it uses a point and it uses the slope. Y equals to mx plus c is the slope intercept form. It tells you the slope and the y intercept. Remember that you have to isolate y, make it the subject. Only then do you have c and m appearing in front of you. Otherwise, if you have 2y, let's say, then that will not indicate the y-intercept and that will not indicate m. If there's a 2 on the other hand, on the other side, you will have to move it to the right hand side, divided by each individual term to get m and c. So that's the first idea. That's something that everybody's done in O-level math, and hopefully if you are at the end of the syllabus, you already know that as well. Parallel lines are lines that do not meet. What do we know about parallel lines that involves coordinate geometry? The gradient of the two lines is equal. For perpendicular lines, the gradients are negative reciprocals of each other, or we can also say that the product of the gradients is -1. We come across both ideas on the exam, so make sure that you know both. When you are constructing equations, only the first idea is relevant, but sometimes when you have unknowns in the question, in points or wherever the unknowns might be, this idea comes in more handy in order to construct an equation. The other is more difficult to sort of construct, so make sure that you know that. Then we have a basic length formula. We have the length of a line, root of y2 minus y1 whole square plus x2 minus x1 whole square. Remember that it's the difference of squares and difference of coordinates squared and then added together. Don't mess up the formula. It gives you errors then, and it's a very basic formula. You should know that. Then there's midpoint as well. And also ask you to find the value of a. That's another question. Midpoint is simply adding up the coordinates and then dividing by 2. What I've realized over time is that with circles and shapes and all those things coming in, the midpoint has become very relevant, especially with circles. So when you're solving questions on equations of circles, always have coordinate geometry in mind, that you can, you know, sort of use midpoints. For example, the endpoints of the diameter have a midpoint that is equal to the center. We're going to come across that as well. Okay, so that's something relevant. Then there are questions in this. I can't possibly go over the questions. When you have a shape that is not there for you, it's often useful to construct that shape, and it's often useful to construct accurate diagrams of the shape. So what I want to highlight here is that whenever you're labeling a shape, either label it counterclockwise or clockwise, whichever suits you. So you can't go P, Q, R, and S. That's wrong. It has to be P, Q, R, S, or if you're going like that, P, Q, R, S. You cannot break the counterclockwise and clockwise directions. Your answers will be all wrong if you do that. Then what are collinear points? Collinear points are points that lie on the same line. They have the grade. They have, if you take pairs of coordinates, they have the same gradients. Then you have equation of a line, something that I've already covered. It tells you, okay, you have to find the gradient and the y-intercept of each line. And that's another question that I've just solved. We've talked about parallel lines. We've talked about perpendicular lines as well. That those questions are about constructing equations. The only things that you need to know are about the gradients. So that is something that I feel we've already covered. Then this is an interesting question. It gives you this equation in a particular form. Remember that when you have equation in this form, x over a plus y over b equals to 1, what you need to understand is that this is like y equals to mx plus c. This is a particular form of the equation. Now, when I talk about particular form of the equation, what I'm basically saying is that it can sort of give you some results directly. What are those results that it can give you directly? Remember that the number below a is basically the x-intercept, and the number below y is the y-intercept. That is only true when you have equals to 1, and when you have a even if you have a negative sign, then basically the y-intercept becomes negative. So the plus is not necessary, it's the equals to 1 that's necessary. This question is more about solving simultaneous equations than anything else. You can pause here and solve this question if you want. It's one from the past papers. Then an important concept is a perpendicular bisector. This is something that you also do in O-level math. You do it in a different context. You do it in the context of loci, and where you are asked to construct the locus of points equidistant from two points. So that results in a perpendicular bisector. What is a perpendicular bisector? The perpendicular bisector is always related to two other points. It passes through the midpoint of those points, and when it passes, it creates a 90-degree angle. So those are two things that you know about the perpendicular bisector. One is about gradients and the other is about midpoints. You can be asked to construct equations of perpendicular bisectors. It's a simple question that often appears for 4 marks. So that's something that you should be aware of. Then that's another question. I can give you this question in reverse. This is sort of an interesting question. I would encourage you to pause the video here and try to do this question if you can, and see if you understand the answer. Then this is often a concept that's skipped by a lot of people, although it's not something different. But this question has come up twice in the past papers, I think. Once in the older past papers and once in the more recent ones. You see, again, this is something that you do in O-level math. You've done reflection and transformations, and you must remember something called a line of reflection. Now, a line of reflection was basically a line that was called the mirror line, and one of the properties of the mirror line was that the object and image were equidistant and created a perpendicular line with the mirror line. So that's something that you need to be aware of. So whenever you are drawing a perpendicular bisector, remember that it's also going to serve as the mirror line. So this question is not different from the other question. It's just that I've given you the equation of a perpendicular bisector and I've asked you to find the other point. Again, this is if you solved the previous question and you paused on the previous question, do this question and you should be able to do it. Again, this is something that's part of the syllabus. Don't assume that reflections are not there in the syllabus. Then you can also be asked to find angles between lines and axes. Remember that angle between line and axis is tan inverse of, now these signs are called moduli or modulus. And what they basically do is they turn any negative number into a positive number. Why am I doing that? Because when I do tan inverse of a negative number, the calculator churns out a negative angle. Now, if you are sort of skilled enough, you should be able to tell me that an angle in this case shouldn't be negative, although it's there in trigonometry, but in this case it should be fine. So even if I were to do tan inverse of -1, for example, the calculator would give me -45, but I know that it has to be 45. So that's something that I know from my calculations. So angle between line and axis is always tan inverse of m. If in case the question asks you for an obtuse angle, what you simply do is you take this answer and you subtract it from 180. This is a formula that comes in handy in particular questions. I've seen this sort of come up twice when you are doing questions on differentiation. There's a particular question about two tangents and those tangents creating angles. So what I always teach is this formula of angle between two lines, although that question can be done in a lot of different ways, but this sort of helps. So what is this formula? It's sort of derived through a lot of trigonometry, and it basically says that if you want to find the angle between two lines, you need to know two gradients. And once you know those two gradients, you can call them m1 and m2. It doesn't matter what you call m1, it doesn't matter what you call m2, as long as you're putting a modulus at the end and turning it into a positive answer, it should give you the correct answer. This formula is not there on the formula sheet, so this is something that you need to remember. Then finding the area using coordinates, it's also called Heron's formula and or Hero's formula. I don't exactly remember. I think it's Hero's, but whatever the case may be, you should be able to do this formula. A lot of questions become simpler when you use this formula, although most questions can be done without the formula as well. This is a particular process. If you don't know the process, I would encourage you to go through this in detail, either in my videos or from elsewhere, but try to understand this. And what this basically does is it uses all the coordinates. So what I've done is I've written all the coordinates x1 y1 x2 y2 x3 y3 x4 y4, and then always the first coordinate repeated so that the shape completes itself. And you can apply it to any shape. If it's a triangle, it's going to be x1 y1 x2 y2 x3 y3 and then x1 y1 again. So in this case, I'm using this to solve for a quadrilateral. You can also use it for a hexagon, pentagon, whatever the case might be. You multiply in diagonals first from the top, you add them together, and then you put a negative sign, you put a bracket, and then you use the bottom diagonals and you add them together, and then you do the calculations as done here. And the final answer gives you the area of the shape that was enclosed with those coordinates, and that is always true. Then I've done a lot of questions here, past papers. If you want to pause, you can pause and then try to solve it. I will not be able to discuss most of them because this is basically just a recap session. So I think I've recapped most of the things that I wanted to. Now, one thing about such questions is whenever you don't have a diagram drawn for you, I strongly encourage my students to always sort of make a small sketch, try to be as accurate as possible. So for example, if you see here, I've done a stupid mistake, and what I've done is, you see the x coordinate is 14 and the y coordinate and the x coordinate here is -6. It should actually be the other way around, and the coordinate should also be the other way around. So you should try to stick to the basic principles, because once you bring in those circle questions into this topic, it becomes very complicated to then do. Again, a lot of questions that we cover in the class. I will not be able to do them here. That's the end of the first chapter. Let's move quickly on to the second chapter, and that is quadratics. Now there's a lot of detail in quadratics. Let's try to be as precise as possible. Now a quadratic expression is basically anything with the variable squared. It could be y squared, it could be x squared, it could be k squared. So that's called a quadratic I'm calling it an expression because it's not equals to something. There's something called the degree of the expression. So the maximum power is 2, therefore the degree of the expression is 2. Then you have quadratic equations. Remember that you should know your quadratic formula. It's also there in the formula sheet. Please don't write the wrong formula. You will get a 0 in the question. If you don't know the formula, just look at it in the formula sheet, although I would strongly suggest that you know the formula by now if you are doing your A-level math. Again, a lot of people ask if we can solve quadratic equations on a calculator. Yes, you can do that, but on the exam, the examiner will expect in some questions for you to have the working. You don't know in which questions the examiner has kept a mark for the working, so it's always safe to at least write this part and then write whatever your two final answers are. You don't need to show me all the calculations, but you need to show me at least the values plugged in into the quadratic formula. So the working that I've done is enough to get you full marks on a quadratic equations question on an A-level math exam. Then there are disguised equations. Disguise can be in various ways. You see this equation, you don't see an x square, but when I take an LCM and an x square is generated and I solve it, again you see an x square but it's inside a root. How do you remove a root? You take it to the other side, you try to simplify the expression, and then to remove the root you square both sides. So once you've squared both sides, you will get rid of the root. One thing that you should be aware of questions that have a root in them by default is that you need to plug in the answers and check, like I've done on this question. Why? Because when I say you have to plug in and check, remember that when a root is part of the question, root of 4 simply means 2. It does not mean plus and minus 2. When does it mean plus and minus 2? When you put the root yourself. If you put a root yourself, you have to take both possibilities. But if you look at this question, a root is part of the question. Therefore, when you are verifying your answer, you have to make sure that your equation balances. You can see in my calculations that minus 3 is discarded, but because it does not balance this equation that I've done here. Then the other type of disguise is higher powers. You will always see powers in this format. What you can do is use a substitution and then sort of come up with solutions for u. Use those solutions for u to find out solutions for x. That's a typical question on the past papers. That's another typical question on the past papers where you have powers in the form of indices, and you can see here the substitution that I've used. So some of these questions will require you to substitute. I've seen these questions also, not this one but the other one. I've seen this come up, example 4, in questions that are part of differentiation, and you're sort of solving for gradients or something, or turning points and so on. Then one important aspect of quadratics is being able to sketch a quadratic curve. Now I've never seen actually a question that will explicitly ask you to sketch a quadratic curve, but when I'm teaching this topic I find it useful to teach sketching because it gives you a fair idea of how turning points are calculated, what are x-intercepts, what are y-intercepts. Okay, one thing that I am recalling right now is one thing that didn't appear in coordinate geometry is about vertical lines and horizontal lines. Remember that vertical lines have the equation x equals to k and y equals to c, where k is the x-intercept and c is the y-intercept. That's something that I forgot when I was doing coordinate geometry and it didn't come up in the book somewhere. I don't know why. Okay, then with quadratics, when you have ax squared plus bx plus c and you have y equals to this, c indicates the y-intercept, a tells you whether it's going to be a smiling face or a sad face. If a is positive, it's a smiling face. If a is negative, it's a sad face. Then intercepts are easy. When you want to calculate the x-intercept, you put y equals to 0. When you want to calculate the y-intercept, you put x equals to 0, although the y-intercept appears here as well. You can do that and verify that you've gotten the correct answer. For the turning point, there are various ways of doing it. You already know differentiation. You can find your turning point through differentiation. That's an absolutely fine method. There are three other ways actually to do this. One thing that I usually teach is that when you have it in this standard form, the x coordinate of the turning point is minus b over 2a. This a and b is the same that you use in the quadratic formula, so you use the values there and you can find the x coordinate of the turning point. If you have the x coordinate of anything, you can plug it into the equation and find the y coordinate. So that's how I found the y coordinate. Then that's one way of doing the question. That's a sad face curve. I've drawn the sketches. You can see the sketches as well. This particular form is basically the x-intercept form. So what it tells you is the x-intercepts directly. You can also find the x-intercepts using you can also find the turning point using x-intercepts. Remember that the turning point is basically the midpoint of the two x-intercepts. So the x-coordinate would always be the midpoint, and that creates what we call a line of symmetry. The line of symmetry is the middle line of the quadratic curve. So it appears the same on both sides then. And that's where I do horizontal and vertical lines. You can also look at that if you want. That's something that didn't come up earlier. Okay, you can also look at the working there and move it up a little bit. You find the x coordinate of the turning point and you find the y coordinate. Now if you have the white Casio classwiz calculator, that calculator is also capable of calculating turning points, so go back and look at that. When you solve a quadratic equation and you keep scrolling x1, it tells you x1 and then x2, and then it also tells you whether it's a minimum or a maximum, and it tells you the vertex directly. The vertex is basically the turning point. This is an interesting question on just turning points. If you haven't seen this before, just try to do it. I can pause the video here and do it. Then we come to what we call the completed square form. Now the completed square form is basically another form. One of the forms was the standard form, the other was, you saw, the factorized form where you could do the x-intercepts. The completed square form is any sort of quadratic equation in this form. You see, it doesn't have a standard position for A, B, C or P or Q. It can be different for every question, although what we use is, if you don't have anything in the question, there is a standard form of a completed square form, ax minus h whole square plus k, where a has the same interpretation and h comma k is basically the turning point. You can also read here what I've written. So if okay, first bringing it into the completed square form, there are various ways of doing that as well. I particularly teach the comparison method, where we expand and we compare. Now that's a process to learn. If you haven't learned that process, if you've done it in a different way, do it in your different way. I find that difficult to teach, and I know for a fact that the other method of completing the square sort of gives you trouble in one particular type of question. It's not that in all questions you'll have that trouble, but in one particular question it gives you that trouble. Then once you have it in the completed square form, what does the completed square form tell you? It tells you the x and y coordinates of the turning point. The x coordinate has to be whatever is here needs to have its sign reversed. So I have minus 5 comma minus 28. What I often tell my students is, you have to take the bracket and you have to equate it to 0 to find the x coordinate of the turning point. Once you have the x coordinate, the value outside is basically the y coordinate of the turning point. Then there are various examples solved here. You can look at all of them. Then the next part of the topic is solving quadratic inequalities. When you have quadratic inequalities, again, there's a process to be followed. Don't rush through this. Your calculator is again capable of calculating quadratic inequalities and giving you the correct answer. So in any case, your answer shouldn't be wrong on the exam, because if you're checking your questions properly, you should be able to get the correct answer. The steps for solving a quadratic inequality are here right in front of you. So what I do is, I gather all terms on one side such that x square becomes positive. I convert to an equation and solve. I find out the roots, and I will always sketch a graph and sort of shade to get my answers. How do I shade? If it's greater than or equals to 0 or greater than 0, I shade in these areas. And how do I use these areas? I describe these areas. This is an area that says x is less than or equals to -1, and the other area says x is greater than or equals to 4. So this is the final answer for the inequality. If the inequality was less than 0, then I would shade here and give you the answer accordingly. I can also give you a question where it's already factorized, so you don't need to expand it, you just need to find the roots. Then the next part of the topic is nature of roots, solutions or x-intercepts. You must have studied something called b square minus 4ac, which is called the discriminant. The discriminant basically tells you how many x-intercepts would be there or how many roots would be there. Roots are basically x-intercepts. Roots are basically for equations. X-intercepts are in the form of a graph. So this is a summary of b square minus 4ac. So that if b square minus 4ac is greater than 0, there are two distinct real roots. When it's equals to 0, there are two equal roots, and when it's less than 0, there are no real root. There is another idea that if it's greater than or equals to 0, there are real roots. I cannot describe whether they are greater than whether there are two roots or just one root. That is something that cannot be described if a question just says it's real roots. The diagrams are also drawn for you just to highlight. Then find the values of p for which the quadratic equation this. You can see the question. A lot of people often find it difficult to find out what a, b and c are. For example, let's say in this question, so when I'm trying to filter out a, b and c, let's try to do that. Let's try to bring everything on one side first. Remember that everything with x square is a, everything with x is b. So what do I see with x? I see a 3 and I see a minus 2k. And what do I see with what do I see as something without x? All the terms without x are c. Okay, lots of questions here that I haven't solved because we've probably run out of time. Then the idea of roots also applies to intersections between lines and curve. Remember that often when you solve a line and a curve, you end up with a quadratic equation. The same principles apply, that if the line and the curve intersect at two different points, there are two distinct real roots. If the line and curve are just intersecting or being tangent to one another, there is one root. And when they are not intersecting and not crossing each other, there are no real roots. The summary is again in front of you. You can read through the summary and pause here if you want. Then there are a set of questions that I've solved. Okay, that brings us to the end of this chapter. Quickly moving on to the next chapter. When I've done quadratics and when I've done coordinate geometry, my next chapter is usually equations of circles. Again, equation of circles was something that's added to the syllabus in 2020. You will see fewer. You will not see any questions before 2020 for equations of circles. I've also done a marathon on equations of circles where I've solved a reasonable number of past papers from 2020 onwards. I think I've solved about 7 or 8 questions on that marathon. Please go back and look at that if you haven't already done the topic. So an equation of a circle is in the form x minus p whole square y minus q whole square equals to r square, where p comma q is the center of the circle and r is the radius. If you have the equation in this form, then you can quickly tell me what the center and the radius would be, and that should be enough about the question. If you don't have the equation in this form and you have okay, before I do that, let's talk about this. If you want to verify whether a point lies inside, outside or on the circle with equation this, then what you need to simply do is you need to plug in the point into the equation and see if the left hand side is less than the right hand side or left hand side is greater than the right hand side. That should tell you whether the point is inside, outside or on the circle. So that can be used for any point inside or outside the circle. It's often useful to sort of draw a small diagram for the circle that you're talking about. Now, when you don't have equations in the standard form or x minus p whole square plus y minus q whole square form, what you need to always generally do on the question, even if it's not stated explicitly, to find the radius and the center, I would strongly encourage you that if you see an equation in a different form, always first change the form and have the center in front of you. Why? Because a lot of questions will rely on your ability to work through the center of the circle. So in this case, I have x minus 1 whole square plus y plus 2 whole square equals to 9. So 1 comma minus 2 is my center. Again, confusion about the signs, always take the bracket and equate it to 0, and that should tell you the correct sign of the number that you want to find. So x equals to 1 and y equals to minus 2. How did I end up with this form? There's this detailed idea that I usually teach, but if I were to summarize this, what I'm trying to do is I'm trying to enclose everything in the form. I don't know if that's written somewhere. I'm trying to enclose it in the form a minus b whole square. Okay, let me just do this here. So I have two terms in x. What I'm trying to imagine is if this was a square, this was 2ab. So what would the value of b be? It would be 1 in this case. Therefore, I've written a bracket x minus 1 whole square. But in order to complete this bracket, I would have added something to the left hand side of the equation. And what I then do is I add something, so I add the numbers to the right hand side of the equation as well, and that is how I get 9. So what I've done is I've added 1 square and 2 square to this side in order to make it 9. Why? Because when I was enclosing these brackets, I had 3 terms, a minus b whole square and y minus x minus p whole square and y minus q whole square. I don't know, this lecture seems to be missing a particular page. I'm not so sure. Okay, so that's something that you need to know when you are doing equations of circles. There is a proper video recorded on that. You can go back and look at it. Again, questions, different things about different circles. Then you need to know specifically these 3 properties, although you should know your properties of circles from your O levels. These are 3 that come in very handy when you're solving questions. Why? Because they're all about 90-degree angles. So when is a perpendicular created? So that's something that you need to know. Radius and tangent create a perpendicular when you drop a line from the center to a chord and you draw it at a 90-degree angle. It drops at the midpoint. That's also something that comes in very handy when you're doing questions on circular measure. So these 3 properties are relevant. Make sure that you know these properties. They're also written down here. And then again, there are a range of questions that I solve. Okay, what you need to know about, let's say this question says it passes through 3 different points that are on the boundary of the circle. Now when you know nothing else about these points, what you need to do is, if you want to find the equation of the circle, you need the radius and you need the center. So always think about the center first. The radius is easy, it's just calculating distances. So remember that this idea that I'm telling you now, that the perpendicular bisectors of chords will always pass through the center of the circle. The perpendicular bisectors of chords will always pass through the center of the circle. So if you have P, Q and R like that, I know for sure that these 2 perpendicular bisectors will pass through the center of the circle. So what I can do is I can create the equation of 2 perpendicular bisectors and I can solve them simultaneously to find the center of the circle, because that's where they will intersect. Again, a range of questions that I solve. These are all questions picked up from books. They're not past paper questions. The past paper marathon is done separately. Okay, that brings us to the end of this chapter. Then I usually teach the binomial expansion. I have a particular way of teaching the binomial expansion. I teach you this formula. It's slightly different from the one that's written in the formula sheet. Why? Because I'm sort of building up for what is going to come in P3. So I say that whenever you have a binomial expansion a plus b something, you need to have two terms inside the bracket. You can't have three terms. If there are three terms, you will need a substitution. That's there in the questions. Then you have NC0, NC1, NC2, NC3, NC4, and it keeps going on till NCN, and the powers of A go in that way and B go in that way. So why do I write it in a vertical format? Because it's easier to sort of then calculate, and at the end I write them together, but it's easier to write. That's the reason I do it in a vertical format. Now I've done a range of questions there. Just finding out different expansions. The questions will obviously ask you for the first two or first three and so on. So that's that. I would encourage you to do this last question that's there, example 4. You can pause here and do it. Okay, then these questions can also ask you for finding specific terms in the question, in the expansion. How I generally teach this is, for example, let's talk about this question. It says find the coefficient of x. So I'm looking for a number that's x power 1. So what I'm going to do is I'm going to write my formula in the form of NCR a power n minus r and b power r. R is the unknown because that's the term that I want to find. I don't know what term I'm finding. It doesn't say whether it's the first term or second term or third term and so on. So I don't know that. Then what I do is, once I've written it in my format, I've plugged in my a and b, I take the powers of x and I take them separately here. So in the numerator I have x power 5 minus r, and in the denominator I have x power r. What do I want? I want it to ultimately become x power 1. So I solve for x power 1, and I find out that when I plug in r equals to 2, I will get x power 1. So that is my that is the term that I am looking for. Lots of questions on this. You should be able to do this. They're in the past papers as well. You can pause here if you want and do this question. You can also pause here if you want and do this question. Then a lot of you get confused when the question has two parts and it asks you for doing a particular sort of comparison. For example, if you see the part 2 of this question, it says find the value of k for which there is no term in x square. When I say no term in x square, what I have a habit of doing is taking the terms in x square and equating them to 0x square and then solve in a normal way. 0x square basically means 0. If you have another term, for example, it says the coefficient of the term in x square is 2, you equate it to 2x square and then do it accordingly. One more thing that's left is for you to know this. These are two outcomes. There's a third outcome that I also want you to know, that NCN is also 1. NC0 is 1. NC1 is n. And NCN is also 1. So sometimes you have n unknown in the question, like you have it in this question. I would encourage you to stop here and solve this if you haven't solved this before. That's for binomial expansion. The next topic is arithmetic and geometric progressions. Now again, this topic relies heavily on your understanding of the formulas. I am going to first talk about arithmetic progressions. Arithmetic progressions are progressions where to obtain each subsequent term you add or subtract a number that's called the common difference. If you want to find the common difference, you can subtract two subsequent terms. So you can subtract term 2 and term 1, or you can subtract term 3 and term 2, or term 4 and term 3, and so on, and you can find a common difference. This is what I call the raw form of an arithmetic progression. You should also be able to write this. This is the formula for the nth term or any term n. The formula sheet uses Tn. I have a habit of using the formula sheet uses un. I have a habit of writing it as Tn. Whatever you're comfortable with, it doesn't matter. So that's something that you should notice. The formulas are there in the formula sheet as well. Then a range of questions. If I give you the nth term, you can just plug in values of n and you can find the first term, second term, third term, whatever you want. You will often end up with simultaneous equations. Then there's a formula for the sum. There are two formulas for the sum. One is more frequently used, which is n over 2 2a plus n minus 1d. The other one is n over 2a plus l. You use that when you have the first term and the last term available to you, or you want to find that and you're given the sum or whatever the case might be. Then again, a range of questions. You can pause here and do some past paper questions if you want. The above one is from the past papers, the one below is not. Then this question often bothers a lot of people. You see, the sum of the first n terms of an arithmetic progression is this. So I've given you this formula for this sum. So if I plug in 1, what this gives me is the sum of one term. The sum of one term is technically then equals to the first term itself. But if I plug in 2, it doesn't tell me the second term. What it tells me is the sum of the first two terms. So I will have to subtract the first term. That is what I do here. I get 14. I subtract the first term, 6. So I get 8 as the second term. Then lots of questions. All multiples are basically arithmetic progressions, multiples of 6, multiples of 7, 8, 9, whatever number you want to take. The other formula that comes in handy, n over 2a plus l in such questions. Here is a formula that I've sort of created. It's just the term formula, in a different format. I tell my students that when do you need to use this formula, specifically when you have n as the n, you're looking for n, and all the other stuff, the first term, the last term, the common difference, and and you're looking for n. So those are the three things that and you're looking for n. Again, a question from the past papers, practical situations on arithmetic progressions. Then you have geometric progressions. Geometric progressions are very similar to, are not very similar, but they sort of have the same build up. So you have a formula for the term, you have a formula for the sum, but in this case you're not adding or subtracting something, you're multiplying something, and that's called the common ratio. It's called OR. Again, what I've written is the raw form of an arithmetic of a geometric progression. That's the formula for the term. So I can again ask you to solve simultaneous equations here. I can give you similar questions. Then there's the formula for the sum, and it's a 1 minus r power n over 1 minus r. It's obvious that r cannot be 1 because it would lead to infinity in the denominator, and it's obvious that if r is 1, the progression won't really be progressing. It's going to be the same term repeated if you keep multiplying by 1 to get the next term. Now, a lot of you might also be thinking that there are two formulas. Honestly, there aren't two formulas. A lot of books will tell you that there are two formulas based on what the value of r is, whether it's negative or positive and so on. So you don't really need to remember two different formulas. One formula is enough, and you will be able to solve questions with just this formula. That's there in the exam as well. This is in the formula sheet, sorry. Some tough questions. Then the sort of arithmetic and geometric progressions usually come together in a question. They are rarely in separate questions. Practical situation questions. Sometimes it's difficult to figure out whether it's arithmetic or geometric. Remember that the basic idea is that if you have percentages, it's usually a geometric progression where you have numbers that, for example, this says increases by 2 liters each day. So that's an arithmetic progression. Whenever you have percentages, remember that if you are trying to obtain the next term that has increased 10%, for example, then your common ratio is not 10%, it's 110%. So that's something that you need to be aware of. So solve this question if you haven't done that already, and that should tell you what I was talking about. Then there's something called infinite geometric progressions. Now, what are infinite geometric progressions? Infinite geometric progressions are geometric progressions that keep on decreasing. The terms keep on decreasing in such a way that a term very far away will eventually come down to 0. So that's the basic idea of an infinite geometric progression, that the term at the end becomes so small that it's approximately equals to 0. So what does that give you? It gives you the idea that you could actually calculate the sum of that progression. You saw the formula for the sum up there, but you can also find the you can also sort of calculate the sum to infinity of that geometric progression. So the terms have gotten so small that the last term isn't actually contributing anything to the sum. It's so infinitesimally small that it infinitely small that it doesn't contribute anything to the sum. So in that case, the formula for sum to infinity becomes a over 1 minus r. There is a restriction that says that modulus of r should be less than 1. What it basically means is that it only applies to ideas where r is between minus 1 and 1. It doesn't apply to other situations. Okay, lots of questions again on this. That's a real life question that you should probably be able to solve. Stop here and solve if you haven't already. And when r is between minus 1 and 1, terms are called convergent. They're called convergent when r is between minus 1 and 1. Remember that. Convergent means okay. Solve this question again, one from the past papers. Interesting question. That brings us to the end of this topic. Then the next topic I have for you is functions. Now, functions is a tough topic, and if you haven't seen the videos properly, go back and see them. It's a detailed topic. It comes up in lots of places. You will see this in differentiation, integration, quadratics, on its own as well. Lots of questions, even with trigonometry. So lots of ideas there as well. So a function is like an equation. It's a relationship between the values of x and values of y. What you have simply done is you've replaced y with a different notation called f of x or g of x or h of x, as is visible to you on the screen, and that's what you've done. There is a change in terminology as well. You don't no longer call it x, you call it domain. You no longer call it y, you call it range. So whenever I'm talking about range, I'm talking about the values of y. Whenever I'm talking about x, I'm talking about the values of the domain, and so on. This is for later on. We'll talk about that. Lots of theory there. These are called mapping diagrams. Now there are basic ideas of what is a function. A function is basically a relationship where for each value of x there is exactly one value of y. So a function could not look like this. Why? Because for each value of x there will be multiple values of y, as is available in this question. In order to check whether something is a function or not, we do something called a vertical line test. Then I've drawn different functions for you. You should be able to replicate these functions, specifically these. These are some things that a lot of students forget, so you need to know this. Now sometimes some questions have restricted domains or restricted ranges and so on. For example, if you look at this, the range is restricted. Why is it restricted? Because this function does not go below the x-axis. So the range of this is basically all values just greater than or greater than 0, not even 0. So this graph does not touch 0. We'll talk about this in a bit. I'm going to come back to it. Basic questions on functions where you replace values of x and values of y. I hope everybody is comfortable with that. Composite functions. Composite functions are where you combine two functions. So f of g of x basically means that you take g of x and you substitute it inside f of x to obtain a new function called f g of x. I hope everybody has done that as well. This says f of x. You need to replace what? You need to replace the function f inside f of x only. Where inside f of x? Wherever you see x, you replace it with the entire function again. So this often confuses a lot of people. This is also something that you need to be aware of. I've seen a lot of people make mistakes here. Lots of functions that I practice in class. And then we come to range and domain of functions. Now, the most confusions come up in this area, range and domain of functions. Now, the basic idea of range and domain is that domain is the values of x for which a function exists. Range is the values of y for which the function exists. So sometimes the functions don't exist at certain values. As you saw in the graph above, the one for the rational function, that the graph wasn't existing below the x-axis. So I'm going to say that if it doesn't exist below the x-axis, the values of y are restricted. So it's a restricted range. There's no restriction on the domain, although there was one restriction where it wasn't touching x equals to 0. So that was the restriction on it. Now, in order to solve questions of domain and ranges, what I strongly recommend is that you always have a sketch of the function in front of you, whether it's a quadratic or a linear or a rational function. Have the sketch in front of you. It's going to be very difficult without having that in front of you. For example, in this question, if you just look at the domain, the endpoints of the domain, they tell you just the boundaries. The turning point is right now absent. Unless I go on and find the turning point myself or I look at the equation, only then will I be able to figure out that this graph was actually going below and then climbing up. So that is something that I need to be aware of in order to find out the range of the function. Another sort of question is here. You can solve this question if you want. This question is often combined with quadratics. Now, inverse of a function. Now, inverse of a function is basically, if you were to interpret it graphically, here's the interpretation graphic, that the relationship between the original and inverse is that it's a reflection of the original function in the line y equals to x. So whenever you reflect something in the line y equals to x, the x coordinate and y coordinates get swapped. So the x coordinate becomes y and the y coordinate becomes x. So that's the process that you follow here. It's written on the screen. I hope everybody who's doing A-level math already knows this process. But if you don't, just go on and practice a few of these questions. I'm going to point out something that I've seen a lot of people get wrong. It's specifically when you are trying to find the inverse of a quadratic function. Now, the inverse of a quadratic function can only be obtained, as it says, from the completed square form. It cannot be obtained otherwise. Remember that. Now, even when you are obtaining it from the completed square form, there is a point where you need to sort of decide. At this point, I brought 7 here, and I said that I have to remove the root in order to make x the subject, remove the square in order to make x the subject. Now, when I'm removing the root, I need to be aware of the fact that when I put a root myself, it's both the plus and the minus outside the root that can appear. But since this has to be an inverse function, only one of those signs can appear. And in this case, it's going to be a negative. Why is this going to be a negative? Why? Because based on this domain that I was given, this curve only exists on the left hand side of the turning point. If this question had a domain that said, let's say 3 to 6, then I would have said that this curve is on the right hand side, and then there would have been a plus outside here. If it's on the left hand side, then there is only the negative part of the curve, and therefore there's a negative outside. There is a more detailed logic to it, but right now, since you're preparing for the exam, remember that a small mistake can cost you 1 mark, and that mark can come in very handy. So make sure that you do this correctly. So whenever you're doing the inverse of a quadratic function, always be conscious of what sign you're putting outside the root. Then another part of inverse is the domain and range of inverse. I don't know where I have written that. Let me figure that out. Okay, I think I've written it up here. Let me just show you this. Here. That for the inverse of a function, the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. Whenever you ask for the domain and range of an inverse function, remember that you have to work on the original function, not on the inverse function. Find the domain, find the range of the original function, and then just sort of swap the variables and you get the answers for the inverse. Never sort of meddle with the inverse function of what it looks like or whatever the case might be. The normal function will always give you the answers to those questions. There are some things about the inverse function written here that's only possible for one-to-one functions, and some details on quadratics as well. You can pause and sort of go back, pause, and do that. The last part of this topic is range and domain of composite functions. Now, this is something that becomes very challenging for a lot of people, and I've seen a lot of people struggle with that. It's not something to worry about a lot. Even if you get 2 marks on the exam that you find very challenging, that's absolutely fine. But it's not something that is impossible to do. Remember that you can still do these questions. Now, to be honest, I cannot review this topic in a recap video. I would strongly encourage you to find that video for range and domain of a composite function, and sort of look at the entire video where I talk about a lot of things, and I sort of come up with rules that I've written here. I'm going to show you the rules right now, so that you can just sort of stop and learn the rules if you want, and that should help you solve a lot of questions. So those are the rules of range and domain of composite functions. Stop here, read through these rules, see if you understand them, remember them as well. Why? Because right now I was solving another question where I had to discard a particular result, and that result was actually based on one of these ideas, why it was getting discarded. So you could have lost 1 mark if you didn't know these ideas. So make sure that you know these ideas well. That's range and domain of a composite function. Again, something that you need to do in detail. There are about 7 or 8 questions in the past papers that are about this, so make sure that you do those as well. The last topic, the last part of this recap video for right now is transformation of functions. So transformation of functions is a new topic, again added to the syllabus later on in 2020. Some of those questions get challenging, but here is a table where I sort of summarize all the transformations. The transformations are, you can sort of divide them into 2 broad categories. Some are transformations on X, some are transformations on Y, and you need to sort of be able to figure them out separately so that you can solve the questions. Whenever there is something happening inside the bracket with X, it's a transformation in X. Whenever it's something outside the bracket, whether it's multiplication or addition, it is a transformation in Y. You can also have reflections in the line Y equals to X. Have I written those here? I think I've written those in a different file, I think. But in fact, I do the reflections here. I can show you the reflections here. So minus f of x and f of minus x are basically reflections on x and reflections on y. So reflection in the x-axis simply means that x-axis is your line of symmetry. A lot of people get then confused. You should remember that when you're reflecting something here, only the y coordinates change sign. So this graph is going to come up here. If you are reflecting it in f of minus x, this graph sort of goes like that. So that's something that you need to be aware of. Again, questions can get very challenging. Sometimes I will ask you on the exam to draw on the exam as well. You can be asked to draw. My screen seems to be frozen. Okay, that is pretty much it for transformations as well. There are other transformation questions that you might find challenging. What I'm going to do is I'm going to record a marathon on transformations as well. So you can look at that marathon and give me feedback if there's any, or you want me to solve particular questions, you can do that too. Okay, that's it for part one of the revision idea. This is a recap video of the entire syllabus. Hopefully it was productive. I will record another recap video for the remaining topics. So please make sure to like, subscribe, and press on the bell icon for updates. Thank you.